Yeah. Hello, everybody. Welcome to this compact workshop. Maybe we're just going to wait a minute or two just to make sure that everybody is here, and then we can start. Okay, so let's let's start the workshop. So welcome to this compact workshop. So I'm going to be talking about compact today, the smart contract language on Midnight. So there are different subjects that we're going to talk about regarding compact. There are three main sections that I would like to divide this workshop in. So the first one is that I'm going to make a quick introduction about compact. So what it is, what it does, what you can do with it, how you're going to use it in your projects and on Midnight when you create a decentralized application. And then we're going to go through some basic concepts of Midnight. So we are going to check one of the example contracts that we have on GitHub, and we're going to go through the contract so you can have an idea about how the contract is structured, how it works, how the different entry points work, and so everything that happens in a very basic contract on Midnight. And to finish, the last section is going to be about more advanced concepts. So there are more advanced features of Compact that you can use when you write smart contracts. And they are going to do different things. So we're going to see, like, for example, how to create modules and how to import them and interact with them. We are also going to see a little bit more the ledger types that you have on Compact. So different types that you can use when you create a smart contract. And we're also going to be talking about token management. So Midnight, so Compact allows you to create native tokens on Midnight. So not only to create them, but also to send them and to receive them within your smart contract. So that's also an advanced concept of using Compact that we're going to talk about by the end of this workshop. So let's get started with Compact. So Compact is a DSL for Midnight. So it's a special language that was created to interact with Midnight, and it's a smart contract language. It looks a lot like TypeScript. So if you know already TypeScript, you will have no issue working with Compact. There are a few subtle things that are different between Midnight and Compact, and between TypeScript and Compact. Sorry. So those are the differences that you should know. So not everything that works on TypeScript works in Compact. So it's a kind of subset. There's a lot of things that you would use in TypeScript that don't work in Compact. So for example, everything that's promises or things like that don't exist in Compact. So the syntax is similar to TypeScript, but the way you use it is going to be different. So there are different things that make Compact a good fit for smart contract. So, for example, there's a strong typing system in Compact, so all the values that you use are safe to use in Compact. There's also, it reflects the dual system that we have on Midnight. So the public-private system, you will see that in Compact. You can use public data, but as well private data that you're going to pass through a witness. So that's something that we are going to see in the first in the first part of this workshop, when we're going to look at the Bboard contract, and I'm going to share my screen, and you're going to see some code, and you can see how it works. And then there's a lot of tooling also around Compact. So I'm also going to show you quickly that you can install a tool suite for Compact, and it's going to help you compile your contracts, verify them, and there's a lot of tooling around it to make your life easier when you work with Compact. So as a smart contract language, if you are used to other languages, like for example Solidity, there are a few things that you will have to keep in mind when you use Compact. So Compact is a language used for Midnight, which is a zero knowledge blockchain. So there are some things to be aware that are different from other smart contract languages that don't have zero knowledge capabilities. So for example, you have to be careful which data is private and which one is public. Although as we are going to see, Compact is going to help you with that, but you have to be mindful of which data is public and which one is private when you write a smart contract. And yeah, then Compact is a very great language for a lot of use cases that we are working on at Midnight. So everything that needs your data to be private, but if you need selective disclosure for your data, that's something that Compact can do. So there are a lot of applications that you can think of, about healthcare or even DeFi. That would be where selective disclosure and Compact is very useful. Okay, so after this introduction, we are. I'm going to check if there are some questions first. Okay. Yeah, so I think at the end of each section, I'm going to check the questions and I will answer them. Okay, let me share my screen now and I will show you the contract. Here. Okay, I think that worked. Where is the contract? Okay, so here is the Bboard contract. So that's one of the examples that we use on Midnight to teach developers how to use Compact. So as you can see, it's a quite simple contract, but it uses a lot of different data type and a lot of concepts that you are going to need when you write a smart contract on Midnight. So here at the top, you can see that there is a Pragma version. So that's the line that's going to tell the compiler that you are trying to use that version of the language, of the Compact language. So as you can see, the latest version is this one, 0.18. And in general, there are some little changes between each version. So it's not always the case. So that's why you see here the range is a little bit larger, but sometimes, yeah, in the new versions there are also new improvements to Compact. So that's why you have to tell the compiler that you are trying to use that language version, and if the compiler is not correct, is not set to compile that version of the Compact language, you're going to get an error message. So yeah, this line is pretty important just to make sure that the contract compiles correctly. Next, so you have that import keyword. So in Compact, you can import modules. So we're going to see that in the advanced concepts. But for example, this module here is the standard library. So it's a module that contains different tools and different types that you can use in your contract to make it easier to interact with data in the contract. Next, so the first type that we see in Compact is going to be that enum type. So first, as we have an import keyword, we also have an export keyword. So here because here it's the contract, it's not a module. The export keyword means that that value and that in that case that type is going to be available from the JavaScript side. So when you are going to import your contract and you're going to interact with it, that enum is going to be available on the JavaScript side, and you are going to be able to use it and pass data to the contract using that enum. So that's what export here means. In the case of a module, we're going to see it in the next section. But in the case of a module, it means that you export the module, and then the module is available to be imported in a contract. So as you are used to in TypeScript, that's how you declare an enum. And here that enum represent the state of the contract. So just to sum up quickly, the B board is a very simple bulletin board where you can post a message, and there can only be one message in the contract, and the user that posted the message is the only one who can take it down, and you cannot post a new message when there is already one. So that's what the state here represent. That either the contract is empty and you can put a new message, or it's occupied and there's already a message and you cannot post a new message. So here it's the type for the state, and here in this line, so it's a very important line where that's where we're going to save the state of the contract. So here you can see there are 4 different values that all start with ledger. So that's the state of the contract. So these values are public, they are saved in the contract, and they are available on chain. So you can query them, you can see them, everybody can see them. So if you put that ledger keyword in front of the value, it means that it's the state of the contract and it's a public state. So here we are going to record if the contract has a message or not. Here we're going to record the message. So you can see that the message has this value. So this type, sorry. Here maybe it's a type that comes from the standard library that indicates either if there is a value or not. So it's something like, if you know Rust, it's something like an option. So here, if there is no message, yes?
Yeah. I wanted to just flag it that you're sharing the wrong screen, so that's why your screen is not up. So I
Oh,
wanted to
okay.
flag it to you. Yeah,
Oh, sorry.
no worries.
Uh, so you didn't see the contract?
Yeah, the current screen you're sharing is the one is the stream
It's
screen.
my face?
Yeah, the face one. Yeah. You can switch to that now.
Uh, okay, just give me a second. Okay, so maybe I'm just going to share the entire screen. Okay. Well, thank you for letting me know because I was going on.
Yeah, it's still
Uh,
okay. When you
and
switch,
here?
yeah, I can switch it now. Just yeah,
Oh, okay, okay.
we can see
So
it
now
now.
you see the contract, yeah?
Yeah, cool. We can see.
Okay, sorry.
No worries.
Um, okay, so yes. Yeah, the thing is that I cannot really see the restream anymore. So um, okay. So now you can see the contract, so you can understand what I was talking about. Let's continue. So yeah, you see the language version. The standard library was here. The enum state is here. The first value in the ledger is this one. So I was talking about that maybe type. So to indicate if there's a value, if there's a message or not. And here you can see one of the primitive types of compact, that opaque string. So there's something very important here to understand, that opaque doesn't mean that it's private. So opaque means that it's opaque to compact. So when the 2 kinds of value that can be opaque at the moment, compact, are strings or bytes. So it means that that's going to be a value that comes from a call to the contract, and compact is not going to care about that value. So it's just going to receive it and to handle it in the way that you want the contract to handle it. But that's it. No, like there's not going to be any sort of formatting or checking or something like that. So opaque here doesn't mean that it's private. It means that compact doesn't really care about the value, and it's just going to save it or things like that. So some very simple operations, not like, for example, if you pass a number, so some kind of unsigned integer, then compact is going to check that it's within the bounds that you assigned it or things like that. So here opaque means that it's just a value, and compact is just going to save it or use it the way you want it. We're going to see in the contract, but it doesn't mean that it's private. Yeah, it doesn't mean that it's private. The third one is in the ledger is that sequence here. So we have a counter. So counter is also a primitive value, primitive type, sorry. And it's a number that you can increment. So there are some methods on it that makes it very easy to increment. And we're going to use it to create a hash for every new message that's posted on the bboard. And finally, we're also going to record the owner. That's going to be some bytes. When a message is posted, we are going to record the hash of the address of the owner. So after setting the state of the contract, we have here the constructor. So it's a little bit like in a class in TypeScript. You have a constructor. So the constructor is a function that's going to be called when you deploy the contract, and it's going to set the state of the contract. So for example, here we're going to set it as vacant. The message is going to be none, so that maybe type has two different values. Either it's none or it's some, as we're going to see it in the next entry point. You have to type it also to tell the compiler that it's going to receive a string. And then we're going to start by incrementing that counter here by 1. Okay, next, we have this witness here. So the witness is a very important concept in Compact. So the witness is a function that's going to be called from the user side, and that's going to allow them to pass some private data. So in general, that private data is going to be the private state of the app. So if your application requires the user to keep a private state, they're going to keep it on their computer. And when they call the contract, they're going to use that witness to pass that private state or part of that private state. And that private state is going to be private. Yeah, of course. But it's going to be private also on chain, so it's not going to be available unless you do some operations that we are going to talk about. But if you just pass it and manipulate it, it's going to stay private, and then you can use it in your contract. So in this contract, we have two entry points. So in the zero knowledge world, they are called circuits. But if you know, like for example, Solidity, they are very similar to entry points. And here we have, those two circuits here, they're public. So here, this one, in the context of this presentation, this one, I mean, not the context of this application, sorry. This circuit here is public because we need it on the JavaScript side to run some tests. Otherwise, this one should be like that. And if it's not public, it means that it's only callable from within the contract. Those two ones here, post and take down, they are public entry points. So it means that from outside the blockchain, you can call them, you can pass values, and they're going to be executed. Let's have a look at the first one. So post. The first entry point is going to let you post a new message. But we have to make sure that there are no messages first. The rule of the bulletin board is that if there's already a message, you cannot post a new one. So here you can see that the entry point is going to take a string as a parameter. And here we're going to use that function here. It's called assert, where we are going to check that the state is vacant. And if it's not empty, we are going to return an error message. So that's the error message. And at this point, the execution of the contract stops, and nothing else is executed, and it returns. So if this condition is not doesn't work, then you cannot execute the contract further, and everything stops. But if the bulletin board is empty, then we have three different operations that happen. The first one is that we register the owner of the message. So here you can see that the way we use it, so we're going to do it recursively. The first one is here's that local secret key. So you see it's the witness that we declared earlier. So yeah, the witness is just a function declaration. No, there's no code because the code is on the application side. Here we just tell Compact that we are going to receive a value of type bytes32. So here the user is going to pass their secret key, and that secret key is going to be hashed with that public key circuit that's here, and the sequence that we initialized a little bit earlier in this one, the constructor. And after so it's going to create a hash, and that's the hash we're going to save in the contract. So that value here is already private, so it's already a hash that the user is passing, and we are going to hash it again. And here you can see that disclose keyword. So it's also very important in Compact. Disclose here means, so if you don't put it, you're going to get an error message when you try to compile the contract. And it happens because Compact wants you to be aware of every time that a private value becomes public. So that's what happens here. When you are going to save the hash passed through the witness in the state of the contract, that value becomes public. So obviously here, it's hashed. So yeah, it's not visible, but still, it's a value that comes from a witness. It could be a private value that could be visible, and Compact wants you to acknowledge that that value is going to become public as soon as you save it in the state of the contract, and that's why you have to mark that value with disclose. So you pass it to that function called disclose, and that way you know that that value is going to become public. And if you don't want it to be public, then you can modify your contract and you can do something else with it, but you cannot save it in the state of the contract. Next, we are saving the message here. So we received that message. So it's a string that's here, and we are going to use sum. So sum is the second branch of the maybe. So maybe can be either none or sum, and it means that there is a value that's saved. And here, once again, you see that you have to disclose it because the parameter of a circuit call in Compact is also private. So here, that new message is private. And Compact wants you to understand that it's going to be made public as soon as you save it in the state of the contract. So that's why you have to disclose it. Once again, if you forget to put disclose, the compiler is going to tell you about it. It's going to raise an error, and you will have to disclose explicitly the value. And to finish, we are going to update the state and set it to occupied. So if someone sends a new message to that entry point, here that assertion is going to fail and the execution of the contract is going to stop. Okay, and now let's go to the last one. So the takedown entry point. The takedown entry point is going to remove the message. So only the user that posted the message is allowed to remove it. So there are going to be a couple of assertions to make. The first one is we have to check that there is a message to take down, because if there is no message, then there's no use to go through the execution of the contract. Here it's going to fail to tell you that it's an empty bourne and there is no message. We also have to check that the user asking to take down the message is the same user as the one who put the message, who posted the message in the contract. So that's what this assertion does here. So it's going to hash that local secret key that's passed through the witness in the same way that it was hashed here before saving it. So if that local secret key is the same sequence of bytes here and here, then it's the same user. And if it's not, then it's going to return an error message here. And so after those two assertions passed, we can continue with the execution of the contract. So we want to return the message that was posted. So here that's the return type of the circuit. Here we're going to save it. In this variable here from a message, and then we are going to reset the contract. So reset the state to vacant. We are going to increment the sequence. So the next time someone hashes if the same user posts another message, then the sequence here is going to be different. So the hash at the end, even if the local secret key is the same, the hash is going to be different. So that's why we use that counter here. And then we're going to reset the message to none, and we return the message that was in the contract. So you can see, like, through in this couple of lines, that the syntax is very similar to TypeScript. I mean, it's TypeScript. Even here, the return keyword, so you have to use it to return the value from the circuit. You call the methods in the same way. Here it's the enum that you can recognize. So it's very easy to learn because it looks like TypeScript. Okay. I'll stop sharing for now. We'll check if there are some questions. Mm. Mm. Okay, I see that nobody could see my screen. Yeah, I'm sorry about that. Okay. Okay. Okay, I don't see any questions about this part. So now I just want to show you some more advanced concepts of Compact. So here with the bboard contract, you can see like some very simple examples and some very basic things that you can do in Compact. So the creation of entry points, assert that some values are valid, and return some other values, that kind of thing, like updating the state and keeping a state in the contract. Now there are probably some more advanced use cases that you would like to implement in Compact, and that's also possible. So let me show you that. Now that I understood how to share my screen correctly. Okay, let's continue. So maybe quickly, I just want to show you. So there is a very useful tool now in Compact that you can download, so you can check the documentation, and you're going to see that how to download that tool. So it's a very useful one, and it lets you do a lot of different things with Compact. And the most important one is to compile your contract. I think it's I remember. I can't remember the comment. Oh, okay. So yeah, for example, you can see the version that you have. Okay, there's a help one. So you see like there are different comments. So for example, a couple of days ago, I had to update my compiler. So you can just type update. Let's see what happens. Update. Okay, so you see it tells me that the latest version is already installed, so I don't have to do anything. So you just type update. It's going to tell you if you have the latest version, and if you don't have it, it's going to ask you if you want to download it. So it's a very useful tool. And of course there are different where is the compile thing? Yeah. So here that's the command to compile the contract. And when you compile the contract, so yeah, let's go to the advanced concept now. So when you compile the contract, so that's the bboard Compact bboard contract that I showed you. After you compile it, you're going to get a folder like this one, managed. So you have different things here. So the most interesting one for this workshop is this one, contract, and this one, the index.cjs. So this file is an implementation of the contract. So that's a file that you are going to use in your application to interact with the contract. So you just have to import it and you can interact with the contract. You can also use it. So at the moment, there's no testing framework in Compact, so you can also use it to test your contract, and it's going to mimic the behavior of the contract. So that's a file that you shouldn't, actually you shouldn't open it. I just want to show you how it looks like, and you shouldn't modify it because that file is generated every time that you compile the contract. Every time that you make modification in the contract, it's going to change that output file. But I just wanted to show you quickly what it does. And at the end here, you have some exports. So those are the values that you are going to be able to use in your JavaScript application. So this one is a class for the contract that's going to have the same entry that are going to have the same entry points like the contract. So the contract entry points are going to be methods on the class. Here you have an implementation of the ledger. Here you can see the pure secrets from the contract. So there are different useful things that you can use when you create an application on Midnight that comes from the compilation of the contract. Yeah, that's the one I wanted to show you. And then we're going to go a little bit into some abstract concepts. So I thought it would be just better to show you the documentation because we have a very good documentation. So you will have a good idea of the kind of things. So there are three things that I would like to show you so you can understand like the range, of Compact and the kind of things that you can do. The first I would like to show you is the ledger data types. So there are some types that you can use in Compact, and they do different things with the contract, and like they are very useful in Compact because they also handle some zero knowledge stuff. And they also, I remember the first times, that I was writing smart contracts in Compact. So coming from something like Solidity, there were some methods that I was looking for, like for example, message.sender. I was trying to find the address of the user sending the transaction or the address of the contract itself, and that's something that you're going to find in this page, in the ledger data types. So, for example, this one, the kernel, there are different methods that are very useful. So methods to compare timestamps. So those two ones here are very useful. The one that you're going to use also is this one, the self. So you call it kernel.self. It's a method, and it's going to return the address of the contract. So that's how you get the address of the contract in your Compact contract. Then sell not too much. Counter, that's a value that we saw in the contract. So when you create a value of type, I keep mixing up value and type, but I hope you understand. So counter is a type, and you're going to create a value of type counter, and then that value is going to have different methods like decrement, increment, as we saw here. So you see, for example, if we go back to the contract, here the sequence is of type counter, and we have natively a method on it that's called increment, where you can pass a number, and it's going to increment the sequence value by that number. There are also some comparison, and you can also read the value that's in the counter at the moment. There are also different types So more complex types. So there are sets, just like in TypeScript. So it's a collection of unique values in no order, just like in TypeScript, in JavaScript. So that you would declare a new set, and then you have different methods where you can insert a new value. You can check if it's empty. You can check if a value is in there. You can remove a value. You can check how many values are in the set. So yeah, it works a lot like TypeScript. No, if you're already familiar with TypeScript, you're going to have no problem using Compact. Again, like in TypeScript, you have maps that also have very similar methods where you can insert values in the map. You can check if it's empty. You can check if a key exists in the map and return the value that's associated with the key. You can check if a key exists in the map, and you can also remove a value by its key. There is also a list type that okay, this one doesn't exist in TypeScript, but I think you have an idea of what it does. So this one is going to be very useful if you need to access the value that's at the beginning of the list. So in general, in functional languages, that's what lists are very useful for. So if you need to put a value at the beginning of the list, and then you need to retrieve it first, and that's how you're going to use a list. And then there are some things that I have never used, but I've seen developers using them. So, for example, Merkle tree, you can use Merkle trees inside your contract. So that's probably maybe something that you need in your use case. So just so you know, the Merkle tree is available as a type in Compact, and there's also a historic Merkle tree that's also available if you need it for your use case. So that was about the ledger data type. So Compact gives you different type of value that you can use in your contract to make it more flexible, make it more useful, and work with different type of data. Next, I wanted to check the modules with you. So that's also something very, very useful if you want, for example, to create a library on in Compact. So, for example, lately I've been working with the Open Zeppelin libraries, and that's something that they implemented. So they created modules, and then you can import these modules into your smart contracts, and you can use them. So that's typically how a module looks like. So that's also something very, the syntax is also very familiar. And so you're going to declare circuits in the module, so they're going to be available after that when you export the module. So here the circuit is just going to work like a function, and it's going to be the same syntax for all the circuits, where you have the name of the circuit, the parameters, and the type of value it returns. You just write your code, and then after that, when you import the module, that circuit is going to be available, and you're going to be able to use it. You can also declare different values inside the module that are also going to be available when you import the module. Also, one very useful feature of the modules is that you can rename it. So, for example, here in this one, we have a module that's called runner with a circuit. And when you import it, you can import it like that. And the name of the module is going to be runner. That's how you're going to use it in your code. But you can also use this syntax here. So import runner prefix, and here you put the prefix, and that's the value here that you're going to use to call the circuits in the module. So I'm going to use, it's not here, but you're going to use some prefix underscore dot run, and then you're going to have access to that circuit from the module. So modules are very good to either to create libraries, but also to put different bits of your code in different files, so you can keep it organized, and you can import the code that you need. You can reuse it. So it's very useful if you have different contracts that are going to use the same bit of code. Then you put it in the module, and you can import that code in every contract instead of rewriting the same code in in every contract. So don't repeat yourself. Okay, so yeah, modules work a lot like what you would expect, with the TypeScript syntax. And to finish with some advanced concept, I wanted to have a quick look at the standard library. So in the standard library, you have different circuits and different types that are very useful in your application. So you remember in the Bboard contract, we use that maybe type. So that's something that comes from the standard library. It would also be very useful for you not to have a look at so the standard library is a compact contract. So you can have a look at it, when you're learning compact. So what I did, you can have a look at it to understand how those types are set in the standard library and how they work under the hood. So there are different structs. So there are like objects in TypeScript. So the maybe one is here. There's another one either where a value can be left or right. Curve point. Yeah, if you ever use something like that in your contract, send me a message, because I would be very curious to know how you use it. All some Merkle tree structs. Here there's one for the contract address. Then here from the standard library, there are some circuits and value that you can use to manage tokens on Midnight. So for example, here the coin info is a struct that holds different information that you are going to use when you handle tokens. So we're going to see a little bit in 2 minutes how that works on Midnight natively. But here you already have a preview of what happens with the coin info, where you can save different values for the token that you are handling. Here's some circuits, so sum and none that we saw earlier in the Bboard contract, left and right for values of type either. There are different methods for hashing. There are some very cryptic things, about elliptic curves. Once again, if you've ever used that, please send me a message. I would like to see what you do with that. Here, so yeah, for example, native token. So it's one of those functions that you can, one of those circuits that you can use to get data, to get more info about a native token. Here you have a token type to describe the type of a token. And here we have the functions that we can use for token management on Midnight. So min token is going to create a shielded coin. So shielded coin is going to be native token on Midnight. That's going to be private. So you can mint it from within your contract, and then you can send it. And one of the main difference between compact and something like Solidity is that when you use min token, you create a token, and when you send it, it actually leaves the contract. So it's not handled by the contract. It's going to be handled by the protocol, and you're going to receive it in your wallet, and you are going to be able to send it somewhere else from your wallet, and then it doesn't belong to the contract anymore. So something very important to keep in mind when you want to use native tokens on Midnight. Okay, there is this one. That's the burn address. If you want to send tokens. Here you have two circuits that are also something a little bit different from Solidity, because of all that mechanism where you can actually you can send the token out of the contract. So that's this function that you use to send it. But if from your wallet you send tokens to a contract, then the contract has to call this circuit called receive, to actually receive the token. No? So to some sort of registering the token, the ownership of the token to the contract. So you have to call that function receive within the contract, and then the contract is going to take ownership of that token. There are also like different functions. So if you have two different balances of the same coin and you want to create one balance, you can use merge coin immediate. This one is the function that you use to get the address of the user that created the current transaction. So that's something very useful, and it's similar to message.sender in Solidity, if you know about it. So that's how you get the address of the user. Yeah, you can also like compare different block times within the standard library. So yeah, those were like more advanced concept of Compact that, yeah, so they are very useful when you want to create a more complex application. So for example, something with DeFi, you can create native tokens on Midnight. You can also create tokens that look like on Solidity, for example, like on Ethereum in general, that are contract based. So the library I was talking about from OpenZeppelin, that's the kind of things that they implement. So you also have that possibility, but just so you know, it's also possible to create native tokens that can leave the contract and be owned by users, and a lot of different data types that you can use and to format your values and to handle different type of data in your contract and make it more useful. Okay, let's see if there are some questions. If you have some, don't hesitate. Okay. Okay, I see. I see a question. Will Midnight Foundation maintain a module library like OpenZeppelin? So at the moment we have something like that. So it's still pretty early. There are different because we're still on testnet, and there are also some features that are not implemented. So for example, at the moment it's not possible to call another contract from a contract in Compact. So there are no contract to contract interaction. So it makes it a little bit more difficult to use something like contract managed tokens, like in OpenZeppelin. But we do have that library. I'm working with it at the moment. It's available. It's open source. You can find it on GitHub. And yeah, it's going to be maintained. And when we have, like, for example, contract to contract interaction, when that's available, then the library is going to be updated, and it's going to make it work properly. Okay. I don't see other questions. If I missed your question, you can send it back. And once again, sorry for the screen. Like, I don't know, I didn't click the right button. Yeah. If you need to have more information about Compact, you can check the documentation. So the documentation is very good. You had a glimpse at it. So it's docs.midnight.network. There are a lot of information about Compact and about other tools that you can use to build application on Midnight. There's also an AI that you can use to ask questions. It's very useful. I use it every day, so it's a very good tool. Okay, so thank you everybody for watching. I hope you learned a lot of things about Compact. Don't hesitate to send me questions. You can find me on the forum, on the Midnight forum, or on Discord, and I will be very happy to answer them. Thank you very much for watching.